And we're live. Good morning or good afternoon. Really happy to be back for another virtual IoT meetup. I think it's been a couple of weeks now since we last spoke. Many of you RSVP'd and hopefully will be attending live this session today. We are joined by Dominik from DC Square. You may remember, if you've been with us with virtual IoT from the beginning, basically, that we've been doing a session on MQTT a long time ago. Well, and MQTT is even older than that, right? MQTT is more than a decade old. Today, we wanted to invite Dominik to tell us all about MQTT 5. You may know that a new major version of MQTT is in the works, and well, even more than that, I guess. So without further ado, I will let Dominik tell us a bit more about himself, maybe, and even more so about MQTT 5. Like always, should you have any questions, please use the YouTube chat to ask them as they come, and we'll keep track of those, and we'll make sure they get answered at the end of the presentation by Dominik. So Dominik, welcome, and the floor is all yours.
Benjamin, thank you. So good afternoon, everyone. It's a pleasure to talk about MQTT 5 today. As Benjamin already said, MQTT 5 is pretty new. A lot of things changed, and yeah, we will walk through the most important changes of MQTT 5 in the next, let's say, 45 to 50 minutes, and then we have some time for questions. Please don't hesitate to ask the questions in the chat. I would like to answer the questions afterwards, after the presentation, but please post them as they're coming, and yeah, perhaps if they fit nicely into the content, we can perhaps answer some of the questions in the presentation directly. So I will quickly share my screen. Okay, but first of all, yeah, welcome to this webinar. I'm Dominik Obermaier. I am the CTO of a company called DC Square. We are located in Germany, and we provide MQTT services since 2012. And yeah, what we do is, besides developing our flagship product called HiveMQ, perhaps some people know of this product, which is an Enterprise MQTT Broker. We also provide professional services for our customers for integrating MQTT into their landscape and to help them form an IoT strategy so they can connect up to millions of devices. If you're finding MQTT interesting and all contents around MQTT, you can follow me on Twitter. My Twitter handle is @theobermaier, which you can also see in the screen right now. Okay, now let's get started.
Well,
first of all,
Dominik, yeah, you actually didn't start sharing your screen, so I wasn't sure before, but
oh, really? Sorry.
That was intentional or not?
Sorry, I thought I pressed share.
There you go.
Ah, okay, okay.
It's fine. It was just the intro, so
yeah, no problem at all. So we didn't miss the important content of the slides. Okay. So, but again, if you're on Twitter and if you like MQTT content, you can follow me here. This is my Twitter handle. But without further ado, let's get started. I guess most of the people joining this webinar are already familiar with MQTT. But for those folks who are not quite sure what MQTT is, what it's about, and what are the main principles, let's start with a quick refresher. This is also important to understand some of the changes in MQTT 5. So let's take a look here. MQTT is an IoT messaging protocol. Actually, not a new and hip protocol. Actually, it's pretty old. It was developed in 1999, but it gained massive traction in the last few years. It's mostly used for device-to-cloud communication and cloud-to-device communication, sometimes for let's say, device-to-device communication directly. And it has a lot of features which are very, very good for, let's say, mobile network use cases where you have devices out in the field like cars, like gateways, or physical hardware, which needs to connect via mobile networks to the, let's say, backend services. MQTT has 3 different quality of service levels, which you can define on an application level. So you can send messages with fire and forget guarantees. But you can also make sure that a message arrives at least once or exactly once on the back end. MQTT has some very, very nice features which are unique to the protocol, like retained messages, which essentially allows you to save messages on your MQTT message broker, which I will tell you in a minute what it is if you are not familiar with the wording. And MQTT also allows persistent sessions. So in scenarios where MQTT is used, you often have use cases where, let's say you have a car and a car moves, and a car changes networks, and what could happen is that a device gets disconnected. MQTT has a feature which allows the client to come back, and the broker remembers the client and also sends out messages the client did not get in the meantime. And in general, from an application perspective, you can program with MQTT like you never lost the connection at all. And one of the things why it got so popular, from my opinion, is it's a binary protocol with a minimal overhead. So it's really, really tiny. It saves a lot of bandwidth, and yeah, it scales massively. So typical use cases for MQTT are push communication use cases. We have reliable communication over unreliable networks. This is mainly mobile networks. MQTT is a very, very good protocol for constrained devices. So if you have don't have too much computing power, if you don't have a lot of memory, then MQTT is a very good protocol choice. So this is typically on physical hardware, where you just have a few megabytes of memory. MQTT has a sweet spot here. But it also scales extremely on the back end. Some MQTT brokers allow to scale to more than 10 millions of concurrent connected devices. And yeah, so we have both, the best of both worlds. MQTT is very suitable for small clients, but you can scale it massively on the back end. And yeah, typically, especially if you're in the mobile networks, you often have a very low bandwidth and a high latency. And MQTT makes sure that you really get the best here. So it doesn't waste any bandwidth, and it has very, very low latency. So how does this work? MQTT uses the publish subscribe mechanism. So we have an MQTT broker, which is here in the middle. And the MQTT broker is responsible for distributing data across clients. So we have some producing clients, like here in this is the Hello World slide for MQTT, with a temperature sensor here, which publishes data to an MQTT broker, and the broker distributes the data to devices, which could be, in this case, a laptop, a mobile device. It could be a car. It could be really anything which can connect to the internet. And this works by a subscription mechanism. So the laptop or the mobile device subscribes to the MQTT broker. It says, hey, I'm interested in a particular data set, and the broker makes sure that only the data which the clients are interested in are forwarded to the clients. So we have a decoupling here. And what is very important to know about MQTT, you have a standing TCP connection here. So all of these devices which talk to the MQTT broker are connected all the time. So this is a difference to other protocols like HTTP, which typically close the connection after doing meaningful stuff. With MQTT, you have an always-on experience. Okay, this was a quick refresher. Let's now talk about the MQTT history. I already said MQTT is not a new protocol. It went in 1999, but it lasted until 2010, until the MQTT 3.1 specification was opened, and it was available royalty-free. And since then, essentially, any developer could develop brokers and clients without having fear of getting sued, essentially. The popular Eclipse project Mosquito was released in 2012 as version 1.0. So, and essentially the Mosquito release was a very important milestone for MQTT, because it was the first open source MQTT broker, and nowadays Mosquito is without doubt the most popular MQTT broker, especially for use cases where you have, let's say, up to 10,000 of devices, and you don't need massive scalability, but you need a very fast broker and a very tiny broker. So it's without doubt the most popular MQTT broker nowadays. 2013, HiveMQ 1.3 was released. It was one of the first commercial MQTT brokers with additional features and clustering capabilities. And also in 2013, the OASIS Technical Committee for specifying or standardizing the MQTT was formed. And in 2014, MQTT 3.1.1 was officially released. And nowadays, MQTT 3.1.1 is the most commonly used MQTT specification, and it is completely open. It is completely standardized, and it is used a lot. But quickly after MQTT 3.1.1 was released, a lot of people used MQTT, and there was a lot of feedback also. So there were some features which just didn't exist in MQTT. There were also there was also some room for clarifications, and this is why the MQTT 5 technical committee was formed. And in 2018, in January, MQTT 5 was officially released and is now an open standard. It is out now, and this is what our presentation is about. And what we also can see, MQTT gained a lot of traction. So this is a Google Trends chart, which shows MQTT compared to other IoT protocols, which are also pretty popular. But we see at least the Google search amount increased over time. And nowadays, MQTT is one of the most popular protocols for Internet of Things development which exists. So, but what actually is the MQTT Technical Committee? Who is participating in MQTT? Well, a lot of companies are participating here. So we have companies like Microsoft, like IBM, Software AG, Cisco, and a lot of other companies which formed this technical committee to make sure the new version of MQTT supports all use cases this company faces with the customers. And so yeah, we have a specification which is used in the industry. And beside all these big players, we with DC Square are also part of the technical committee. And of course, we also gave back the feedback we got from our customers for our HiveMQ customers. So let's talk about MQTT itself, MQTT 5 itself. So what is MQTT 5? MQTT 5 is the successor of MQTT 3.1.1. So there is no MQTT 4. Instead, the technical committee decided to go straight with MQTT 5. I will tell a bit of backstory later on why this is not called, let's say, MQTT 4 or MQTT 3.2. It is not backward compatible to the old specification. The broker vendors can decide that they can, let's say, backport some of the features and also make sure the old and new version of the protocol are compatible, but the specification itself is not about backwards compatibility. It was officially released in December 2017 or January 2018, So actually, it was released shortly after Christmas, but I guess most people noticed that it's publicly available in 2018. And it also has a lot of clarifications from the MQTT 3.1.1 specification. So to make sure that implementers of the specification get everything right. The goals that TC had in mind were enhancement for scalability and large-scale systems and improved error reporting. Especially improved error reporting was one of the most wished features by users, because MQTT 3 had some blind spots when it came to error handling. And so MQTT 5 did a lot of work here. And it also formalized common patterns like request response, which we'll also cover in this presentation today. And one of the most wished features by users was also the extensibility of the protocol. So because there weren't, let's say, headers like people know from HTTP, MQTT wasn't that flexible. This changed with MQTT 5. And of course, performance improvement for small clients were also a big part. And yeah, MQTT is very, very easy to program on the client side, but it's important to notice that implementing an MQTT broker is not as easy as it sounds. And this is also what MQTT 5 did. There were some enhancements for the scalability. Nowadays, MQTT 3 brokers like HiveMQ scale to up to 10 millions of devices, which is already a lot. But also we expect that MQTT 5 allows to scale even beyond the magic 10 million by concurrent connections border. Before digging into the specific features, let us talk about the foundational changes of the MQTT protocol. So foundational changes were negative acknowledgements. I already mentioned that the error reporting in MQTT 3 wasn't always optimal. So when a client did something which he was not allowed by the broker, so let's say a client published to a topic it was not allowed to publish to, then there was no way for the broker to tell the client, hey, you're doing something wrong here. And so what was defined here were negative acknowledgements. So a broker can actually notify the client that something went wrong and also what went wrong. This is, for many use cases, this is very important, especially for production use cases where it's hard to debug what happened. And so the client can react when something weird happens. But also the client can send acknowledgements to the broker if something bad happens. So another foundational change are return codes for unsupported features. When a client connects to an MQTT broker, the broker, if it does not allow all MQTT features or doesn't implement all MQTT features, which is pretty common at typical cloud platforms like AWS, then now it's possible to tell the client, okay, this feature is not available, or this is not available for you if you have a permission control and you do not allow clients, let's say, to subscribe or publish or something like this. And what we can do with MQTT 5, we can restrict the retain message feature, so we can turn it off if we want for specific clients. We can define a maximum quality of service level for a client. We can restrict the use of wildcard subscriptions. We can also restrict subscription identifiers and share subscriptions, which we'll cover also today. And a client can be notified what the maximum message size the broker supports is, and also what the server keep alive value is, which is also very important because it's also a change. With MQTT 5, the broker can tell the client how often it should send ping messages or heartbeat messages in order to recognize if a client is offline. What is also streamlined is the session state or the life cycle. So you don't need to understand this slide in all details. if you, this is actually from the Eclipse community newsletter from September 2016. The link is at the bottom. And but what you can see here is on the left you have MQTT 3.1, and on the right side you have MQTT version 5. You can see here it's a lot more streamlined and easier to grasp how a session state should change when specific events occur. Like on the left side you see network breaks, disconnections, connections, and so on. And on the right side, what you can see here is, okay, this streamlined, the state machine is pretty easy to implement on the broker and on the client side. And this is also something which caused a lot of bugs in some client implementations and also some broker implementations in the past, because the state machine for MQTT 3.1 was pretty hard and has a lot of exception cases. But what is also important to note here for you as an application developer, there isn't much that changed. So this is just for the implementers of the client and the broker implementations. But I guess it's also, if you're interested in that, you can click the link or go to the Eclipse community newsletter for 2016 in September and read about the state transitions which changed. So other notable changes in MQTT 5, now it's not allowed to send retries for quality of service 1 and 2 messages. This is something which may come surprising for some people, because we noticed that many projects rely on retries, and retries are not allowed with MQTT 5. So this is a common pitfall when upgrading to MQTT 5. So it's very important to understand this. What also changed, this is something small. Passwords are now allowed to send without having usernames, which may be interesting for sending tokens. You can, and also the broker and the clients are now allowed to send disconnect packages. Traditionally, the broker has no way to disconnect the client gracefully. So with MQTT 3, the client can connect, and when it decides, okay, I want to disconnect now in a graceful fashion, then the client sent a disconnect packet to a broker. But now it's also allowed for the broker to send a disconnect packet back to the client and tell the client the reason why it was disconnected. This is also something new and is used heavily for the negative acknowledgements, as said before. And on a low-level perspective, we have new data types. This is interesting for implementers, but it's not that interesting for, let's say, application developers. But there's also now a new string pair, UTF-8 string pair, and the protocol version changed for MQTT. There is some trivia around it, which is, I think, pretty interesting. It's important to notice that MQTT 3.1, which was the first version released back in 2010, it had on the wire, on a byte, let's say on a byte level perspective, it had version 3. It was just version 3. And when MQTT 3.1.1 came out, the TC decided to use the number 4 for this protocol version, because only integers are allowed here. So what happened with MQTT 5? Yeah, the TC decided, okay, let's streamline the name and the protocol version on the wire to avoid confusion. And so now everything is just called MQTT 5. Okay, now let's talk about some of the features. So actually, we cannot dig into all features because there are more than, I think, 25 features available, which would take a lot of time. But what I want to try is here highlight some of the features more in detail and mention the other features. And I give you some resources at the end where you can learn more about the features in depth without reading the whole specification. So one of the, from my perspective, more interesting features of MQTT 5 is session and message expiry. So what are we talking about here? when MQTT allows two kinds of sessions, or traditionally allow two kinds of session. We have a clean session, which is a session which ends when a client disconnects. So the broker does not need to remember anything about the client. And we have we call it persistent session, which is a session the broker saves and persists. And when the client is offline and comes back, the client can just resume the session. So essentially what we get here is we have a state on the broker side. The problem here is if we have some clients which connect to the broker, disconnect, and never come back, the broker can have a very hard time because it needs to persist the data until the client reconnects. And when the client never reconnects, essentially we get a problem here. And most brokers like Mosquito and also HiveMQ allow to set a time to live for sessions on an administrative level. So the broker can clean up after this time. But with MQTT 5, this feature went back to the specification, and now all brokers must implement a cleanup because this is needed. This is needed on the broker side, because otherwise it would be prone to denial of service attacks. So the client can say, okay, when I'm connecting to this broker, I want a session expiry interval in, let's say, 100 seconds or 10 minutes or 1 day. And then the broker is allowed to delete the session after this time. And yeah, it's not just on a session level, the expiry. This is one part. With persistent sessions, I already said that when a client is offline and is subscribed to some messages, then the broker can queue the messages the client did not get. And when a client comes back, it will send out the messages, all messages it received, or all messages which the client missed. The problem here is if, let's assume we have a car which was offline for 1 week, and when it comes back, does it really need to get all messages it missed in 10 days? Probably not. Perhaps some messages not. And now a sending client can send a publish expiry to a published message and says to a broker, hey, please broker, if the time to live is over, do not send out the message anymore because it's not valid anymore. And this allows the broker to clean up messages, especially if it queues the messages. And also it saves a lot of bandwidth, because if you send out messages to clients which you're not interested in, you essentially waste bandwidth. So, and one feature I already started to explain is negative acknowledgements. But now let's dig a bit deeper. MQTT 5 has so-called return codes for all acknowledgements. These are essentially the conACK, PubACK, PubRec, PubRel, PubComp, unsubACK, disconnect, subACK, and the auth package, which is new and we'll also cover today. So now the broker and the client can say, sorry, we have a problem here, and this is the problem. There are reason strings defined, which are human readable, which the broker and the client can send out if they want to, but they don't need to do this. And and also it sends a return code. These return codes are specified. Most of them are error codes, and all client and broker implementations must have the ability to react to this return codes. So if you're a client and the broker disconnects you because you were, let's say, idle for too long, then you have the possibility on the client side to adjust the interval for sending heartbeats, for instance. But what you can also do if the broker disconnects you because it is overloaded at the moment, then it would be smart on the client side to say, okay, the broker is overloaded, so don't just reconnect, but wait for a few seconds so the broker has some time to get healthy again, for instance. So you get a more fine-grained error control on the client side, how you react to circumstances. And the new disconnect package, which the broker is allowed to send to the client, can also carry all of these error codes. And actually, it has a lot of error codes. And we expect that this allows the application developers to build much more resilient applications than it was possible with MQTT 3. One thing which is interesting about MQTT 3 and also the new version is it's a binary protocol. Binary protocols are very, very good for machines. Machines, literally speak binary, but humans are not that good in reading binary stuff. And also application payloads isn't always binary. So a client could send, for example, XML files or JSON files or some textual representations or some text. And MQTT is not interested in the actual payload and also not in the format. This is something a lot of customers, we saw a lot of customers, they really wanted to have some indicator, okay, what kind of payload do I actually consume, like MIME types we have with HTTP. So it's easier for the client to figure out how it can interpret the payload. And now MQTT 5 allows this. This is part of the specification. So what we get here is a content type. This is similar to MIME types, like, okay, now we can say, okay, this is a JPEG picture, or this is a UTF-8 text, and so on. This can be sent, this meta information can be sent by the sending client. And also, what is interesting, these indicators, what kind of content do we have, is also possible for ACK messages. And we actually get two new headers here in MQTT. This is the content type, which I said is the MIME type. And we have a payload format indicator. This is more interesting for, let's say, debugging purposes. So the sending client can say, okay, hey, we have binary data here, or we have text data, UTF-8 data. So what a broker implementation could, for instance, say, okay, we have a text data here. We can, let's say, log the message because we can interpret it. We can write it to log file. And the broker could also decide, okay, we have a binary data here, so we do not want to interpret it. This may be a small change, but I believe for debugging purposes and also for development of new MQTT applications, this might be pretty useful. Also for humans, if humans want to dig into the actual contents. Tools like MQTT.fx, which are end user tools or tools for users, have features like, hey, interpreting the data. So if you use MQTT.fx, it allows to say, okay, this is a JPEG data, this is a text data, and then it interprets it as a text. And with the payload format indicator and the content type, these tools could adjust their settings automatically based on the messages they receive and give the user meaningful representations of this data. So again, I think this is very interesting features, and this is something which is not a very prominent feature, but it may save developers a lot of time debugging applications. Okay, this is a controversial one. MQTT implements the publish-subscribe pattern. It does not do request response like HTTP or CoAP does. This means clients are always connected and the broker sends messages. But oftentimes, developers find themselves in situations where they have a producer of content, a publisher, which sends data, and there is one or more receivers. And then they find themselves in a situation as when the receiver receives the message, and then it processes some data, does something meaningful, then it needs to send back a message to the original publisher, okay, I'm done, I received it. So we call it here at DC Square, and our customers call it business acknowledgements most of the time. And you could also do this with MQTT 3. So I know a lot of use cases where this is implemented, but this is not possible on the protocol level, but it's essentially application specific. And MQTT 5 standardizes behavior. And now it's possible to send hints, like you want to do request response. So yeah, what you can do here is you can send metadata like request response information. So a publisher can send a message, like can send a message, and it can also send a metadata. Hey, dear receiver, I expect an answer for this publish on another topic. And then the request response information header can be used that the receiver of the message can send the answer to this topic. And I'm not, honestly, I personally am not convinced that this is something which will be used frequently. It is very controversial. But I guess if you have a request response problem you want to solve with MQTT, this can be a lifesaver. Okay, let's go to another feature, shared subscriptions. This is also a very interesting feature. It's also available for some MQTT brokers nowadays with MQTT 3.1. So brokers like MessageSite, HiveMQ, and also open source brokers like I think VernMQ support shared subscriptions, but this is not a standard behavior. So Mosquito, for instance, does not support yet shared subscriptions for MQTT 3. Shared subscriptions are a very interesting concept for scaling out backend subscribers. Let me demonstrate this with a picture because this is easier to show. Let's assume we have a publisher which sends a lot of messages. So we have a high frequency topic. A problem which could arise is that the backend client cannot process data this fast, because let's say it writes to a database, it writes the messages to a Kafka backend, which is slow at the moment, and so on. So what to do? How can we scale this? With MQTT 3, you cannot scale this without using shared subscriptions, and this works like the following. We have a logical or a virtual shared topic, a shared subscription. These are the boxes here, and clients can decide, okay, I want to share my subscription with other clients, and then the broker can send one message to the one client, one message to the other client. And so essentially, if you have a stream of, let's say, 1,000 messages per second on a topic, and you have a shared subscription with 2 clients, then each of these clients gets 500 messages per second. And now if you scale out to 3 clients, then each of these backend instances gets 330 messages per second, and so on. If we would scale to 10 backend services, then each of these services gets 50 messages. Gets 100 messages instead of 1,000 messages. So this is a way how you can elastically scale up the backend subscribers or clients up and down for topics which have a lot of traffic. And this is something we see a lot in real projects and in high scalability projects. And we expect with MQTT 5 that we see a lot of more of these applications. Okay, let's talk about user properties here. I already said MQTT 5 has headers, allows to use headers. And now it's finally possible to use user-defined properties, which is you can just like with HTTP add any data you want to your MQTT packet, and essentially to any MQTT packet you can wish for. So your load balancer wants to add some metadata to the backends. No problem. It can modify the publish and add user properties. Or let's say you have a publisher which has some application specific identifiers, for instance, which you want to parse in the backend without looking into the whole payload of the packet. You can just add a header here, and the backend applications can just get out the header without decoding the whole message, and so on. And you can add unlimited user properties. which is a bit controversial, honestly, because it adds a lot of flexibility, but also has a lot of potential for misuse. But this is something I personally expect that it will be used a lot, and it allows to implement a lot of use cases. And actually, the same mechanism is used for most of the MQTT features we talked about. And yeah, application developers can simply use this with very simple APIs. And we'll talk about the Eclipse Power projects and other libraries in a few minutes. And the APIs are very easy to use for adding user properties. So I guess this will be the new standard for most applications to use these user properties. Okay, there are so many features here. We cannot cover them all, but let me give an overview. We have now topic aliases. So clients can choose to shrink topics if they have a very long topic, which they repeatedly publish to. And then they save a lot of bandwidth because they can just use an alias. We have flow control, so some kind of back pressure handling. So a client can decide how many messages it can actually receive before it says to the broker, hey, please stop, I cannot receive anymore. We have maximum message size indication. We have an authentication flow. We now, MQTT 5 supports, beside username and password fields, it supports the SASL framework. And now you can do, let's say, Kerberos, or you can do Scrum or any other more sophisticated authentication method with MQTT. We also get will delay. You can tell the broker, hey, dear broker, please wait, let's say 5 seconds before sending out the last will and testament message. If I come back in this time, please do not send out messages, for instance. We have subscription options where you can fine-grain tell the broker, hey, I do not want to receive messages I'm publishing myself, for instance. The broker can tell the client what keep alive it expects. The broker can also override the client identifier or just assign a client identifier to clients if it chooses to. And the broker can also say to the client, hey, client, sorry, let's say I'm overloaded, please use another server. So we have redirects with MQTT 5. And there are some other features, small features, which are very interesting, and I will tell you about the resources where you can read about them just in a minute. So, but the question here is, okay, nice, we have a lot of new features, it sounds exciting and stuff, but should we upgrade yet? The answer is not that easy to, it's not that easy to answer. Let's check first with broker compatibility. What brokers are out there which support MQTT 5 at the moment, now in March 2018? Let's look at Mosquitto. Mosquitto is, as I said, without doubt, the most popular MQTT broker. But at the moment, there is no MQTT support yet. And at least I did not find anything about an announcement for MQTT 5 compatibility yet. And there are some development activities on GitHub, but it doesn't seem that they're ready for prime time yet. So, and there weren't too much MQTT 5 development activities recently, at least no publicly available development activities. I personally hope that Mosquitto will have MQTT 5 compatibility very soon, but at least of today, it's not possible to use Mosquitto with MQTT 5. HiveMQ, which is the product of our company, does not have MQTT 5 support yet. We will have an early access version for MQTT 5 in the second quarter of this year. If you want to get notified about this, here is a link. You can visit where you can subscribe, and we will send you an invite as soon as there's the early access available, of course for free. And we will have 100% MQTT 5 support in the third quarter of 2018. HiveMQ will be completely backwards compatible, so it will be possible that your MQTT3 clients talk to your MQTT5 clients and vice versa. And HiveMQ supports more than 10 million of concurrent connections, and of course, all MQTT5 features will be supported in the same scale, and we expect to scale even higher with MQTT5. Okay, let's talk about other brokers. There are many broker implementations out there. Unfortunately, I did not find any MQTT5 broker yet, except the Eclipse PAHO test broker written by Ian Craigs, which is very good if you want to implement MQTT5 yourself to take a look. But this is not a broker for production use. Also, I did not find any, or do not know of any, Internet of Things software as a service which offers MQTT5 support yet. And also, be sure this is important. Some features of MQTT5 are optional, and the broker can actually tell your client that it doesn't support specific features. So this is something which also will be getting a bit harder if you want a specific feature set of MQTT5. So it's here important to check what MQTT features are supported, because it's possible to have a 100% MQTT compatible broker, but it doesn't support all features because it is allowed to tell your client that it does not, let's say, support retail messages or other features. This is just something to bear in mind. Okay, so wrapping things up, let's talk about client compatibility. So here we do not have any brokers yet, which you can use, unfortunately. Let's talk about Eclipse Power Java. There are development activities. It's not yet in Maven Central, unfortunately. The developers seek active feedback, so please try it out and give feedback on the mailing list or on GitHub. And MQTT5 support for PAHO is planned, as far as I know, in June 2018 with the Eclipse release train. So I guess we get MQTT5 support here in the second quarter of this year. The Eclipse Power Go library is in development for MQTT5, but I did not find any recent development activity. But I'm hoping that this will also be part of the release train in June. Looking at the C client, it's very actively maintained. It has an MQTT5 branch, and as far as I know, it's also planned for June 2018. And also, the developers seek feedback here, and yeah, so please provide feedback. Another library which is new is there will be a new MQTT library in March and April 2018 for MQTT5 and 3.1, which will be an open source library, a completely reactive library, so it has a bit of different scope than Eclipse PAHO and has built-in back pressure handling. It is built for backend systems mostly, so not mobile devices, but backend systems. With high scalability in mind, and it supports many tens of thousands messages per second to process. So it aims to be high scalability library. And yeah, this is created and maintained by us, by the HiveMQ team, and also by the BMW car IT folks. So they, this is also a library which will be available very soon. So to wrap this up, as you can see, MQTT5 has a lot of features everyone can profit from, but unfortunately, there aren't broker implementations out there yet. No client implementations out there yet. The first client implementation will be the MQTT in March or April, end of March, beginning of April, to be available. But again, no broker implementation is out there. So I think it's important to know about MQTT now and to plan for MQTT5. But it's not ready for prime time because of the lack of implementations, unfortunately. Also, if you want to implement clients, brokers, either yourself or want to contribute, the whole IoT community would be very grateful for your feedback, and also if you want to develop actively, I guess everyone is happy with this. You can learn more about MQTT5 on mqtt5.com, which is a blog post series. We also write. It's not finished yet. It just started, and each of these features we talked about here will get an in-depth blog post with all the technical nitty-gritties. if you're familiar with the MQTT essentials, this will be essentially the MQTT 5 essentials. And also, if you're interested about IoT, there's also a book which I also co-authored, which is more of a broader scope, the technical foundations of IoT, which also has some information about MQTT and other IoT protocols. Okay, so I guess it's time for some questions. Thank you for listening. I hope it was interesting for you. I hope you're not too disappointed that MQTT 5 is not there yet, at least not implementation-wise. But I guess in the, let's say, in the summer of this year, we have a lot of implementations and yeah, the first deployments, which I know of, will perhaps go live in the third quarter of this year with MQTT 5. So exciting times ahead. Please, if you did not ask the questions yet, you can now post them to the comments. And I think we have some minutes left, so we can answer some of them. Thank you.
Well, and thank you, Dominik. There's actually many questions, so I will be sending them your way in no particular order, or at least like in the order they came. Some of them will be on very specific details. Some of them might be more generic. Starting with Dan, what is the reasoning behind the removal of the retry feature?
Oh yeah, this is a very good question. There are many things to consider here. So essentially, we have TCP. When we use MQTT, we always use TCP or protocols which have the same, which also allow to use features of TCP. So like we have, it's ordered. TCP is always ordered, and we get a stream of bytes, for instance. And also TCP retries itself. If you have an active connection, there is essentially no need for retrying.
Makes sense.
Yep.
Yeah. Well, there's lots of questions, so maybe we can move on.
Okay. Just one thing to add here is, and the problem is it doesn't make it better if you retry, because if the broker is too slow to respond and you just push more data in, it gets overloaded quickly, and vice versa for the client. This is the reason.
Right. I think you sort of mentioned that a bit, especially like for end users and application developers. It might not be a big deal, but like, can you comment on the, and this is a question from Jörg, how much effort you see for migrating an application to V5?
Not that much. If you're happy with the feature set of MQTT 3, I think Eclipse PAHO is pretty backward compatible with the API. So I guess it's pretty easy. If you want to add new features, of course, you need to develop it, but just upgrading might be pretty easy, at least on the client side. And on the broker side, it depends on the broker vendor you're using.
All right. So, well, I guess this is also the point of Paul's question. He's a bit concerned about backward compatibility. So how should it be handled, especially by client already implementing the previous version?
This also depends on the broker vendor. So we did a lot of research here, and also we made sure that the MQTT 3 client will just get data which it can interpret, and also MQTT 3 client can send to MQTT 5 clients. I'm not sure about the roadmap of other brokers, but at least for HiveMQ customers, it's just upgrading and nothing changes. You can just plug in your new MQTT 5 clients.
Yeah, okay, sounds good. Another question, when you started to talk about the session expiry mechanism, what happens when it is not provided? Is there a default expiry of the messages? And actually, I think there was another question related to that. Like, are there other? Yeah, no, that will be another question. So, how about you take that one first?
There is no default here, so it's unlimited, if I remember correctly. But your broker usually will provide a config if you are not happy with the default config.
Okay. Yeah, now I found the other question that was somehow related. Bor was asking whether the retention policy for making the session expiring, if it can be more than just an expiry date, for instance, based on the amount of messages or like the space that the messages are taking.
No, not on the protocol level. On the protocol level, it's just time in seconds. But again, this is usually something a broker might allow to change.
Okay. Another question on, I think, to the point of is MQTT v5 vulnerable to denial of service kind of attacks with the user properties mechanism? It looks like the packets can be bigger or even much bigger. Can this be dangerous somehow?
The TC did a lot of had a lot of thoughts into discussing the denial of service attacks. At the end, it really depends on the broker, let's say, implementer. But there are a lot of hints here and also a lot of recommendations how one can prevent this. So I expect that the popular brokers, at least, are not vulnerable to such attacks.
Yeah, it makes sense. I guess this is good, all the network protection measures and stuff like that. I think that's it for the questions. So there were lots of them in the chat. If people have more questions and are watching the recording of the session, feel free to use the comments, and we'll be maybe Dominik will be monitoring them, or if he's not, we'll be making sure that those questions get answered. I think there's also a nice, I hope I got that right, but I think YouTube is now recording the chat, the live chat for when we do the live recordings. So some people might want to, watching the replay, might want to keep an eye on the chat. There was some really good discussions there today, and Ian Craggs, actually from IBM and from the Eclipse PAHO project, has been really helpful. Thank you, Ian, by answering some questions about Eclipse PAHO and other stuff. So that was really a great session. Like Roxanne just posted in the chat, we will be back on March the 21st, so in 2 weeks' time. The session will be with David Simmons from Influx Data. So you may know that Influx Data is the company behind InfluxDB and many other projects. So yeah, we'll talk about time series database for IoT, basically. So I'm really looking forward to that. We didn't announce the meetup just yet, so stay tuned. If you want to learn more about MQTT5, and this is kind of a semi-private joke for Ian Craggs, who I know is watching the webinar, but yeah, we as in Eclipse, the Eclipse Foundation, we are organizing an event in the Bay Area in Santa Clara on May the 14th. And we will be announcing the program very soon. But the program will actually include a talk about MQTT5 by Ian Craggs and many other great talks about Industry 4.0, time series databases, machine learning for IoT. So yeah, we will make sure to keep you all posted about that. And with that, I think that's a wrap right at the top of the hour. Dominik, thank you again. That was really a great session. Like you said, or I believe you said, or at least we said in the chat, the slides will be on SlideShare really soon, so people can use them as the reference, and there were a few useful links in those as well. So yeah, thank you very much, and we'll be back in 2 weeks' time.
Thank you. Bye.